Okay, so we are in the October-November 2021 paper, and we are going to do number 6, okay? That's our focus. Let's see. And we are here. Here's the question, and it's saying calculate AD, okay? So as we know, it's a trick question, right? Because from here, I can see that I have two triangles, and they want me to find AD, okay? And AD is this. That's what they want me to find. Now, these are two non-right angle triangles, so I know I'm in sections here. Either I'm going to use the sine rule or the cosine rule. Now, to get AD, which triangle is AD in? I'm going to show the other sides, the other triangles. I'm going to do the other sides of the triangle, rather. I'm showing them in red. So there we go. This is the triangle that AD is in, the one in red and blue. Okay, ADC. Now, ADC, what does it have? I can see that I have an angle here, and I have an angle here, and I have a side. Okay, so the question I ask myself, do I have an included angle? No, I don't. Do I have three sides? No. So I can't use the cosine rule. So I know I'm going to use the sine rule. Okay, I'm going to use the sine rule. But I need to label my triangle, put the letters. Opposite vertex A, or the angle A, is going to be side small a. Okay, so I'm going to put it like small a. Then opposite C is going to be small c. Okay, so I can put it as a small c. And then opposite D, this side is going to be the small d. So basically, I know that I'm going to use the sine rule since I don't have I don't have an included angle, and I don't have three sides. So cosine rules out. Now, what is side AD? It is C. So since I'm looking for AD, which is obviously a side, because once you see two letters, it's a side. So since I'm looking for AD, I'm going to use the the sine rule, which has the letters on top, right? Or which has the sides on top. So I'm going to say, I can say A over sine A, because I have A, D, and C in my triangle. So this is going to be equal to C over sine, capital C, which is equal to small d over sine, big D, right? Now, which side is not involved in the question? I'm looking for AD, which is C, right? And what do I have? I have AC, and I have the angles and stuff. But look at A. Do I have anything on A? No. I don't have the angle, and I don't have the side. So A is out, right? So I'm going to cancel it. So that means for my thing, I'm now going to write for the work, what I'm going to submit to Cambridge is going to be C over sine C is equal to D over sine D. Now I'm looking for side AD, which is small c, right? So I'll take sine C to the other side. I'll say C is equal to D, over sine D times sine capital C. So I can therefore say C small c is equal to, what is my D, small d? Small d is 12 over sine capital D is 100. You can see it from there. And then multiplied by sine C, which is going to be sine 50. So you can now say C is going to be, there we go. We can go ahead and get our solution, and we will be done. So we can get our small c, and we know that that would be the AD. So we can therefore say AD will be whatever the answer is going to be in centimeters. So let's go ahead and let's calculate it, and let's get it. And for here, we'll get the answer 9.33. Okay, I hope you got the same answer as me. 9.33 centimeters. Okay, and the reason the reason that we put 9.33 is because they want answers that are not exact to be to 3SF. Okay, so we can say this is 9.33. That's three significant figures right there. And you're done. Calculate angle BAC and show that the answer is going to be this. When you round it to two decimal places. So let's go to angle BAC. Which one is that? It's this one. We'll call it theta. BAC, okay? So it's right here at A, and it's in that BAC thing. Great, so I'm looking for this angle. And that means I'm going to remove this whole thing that I put with a pencil. I'm removing it. Now I'm looking at this triangle right here. Down below. Now, what do I have for this triangle? I see I have this side is 12, this one is 8, this one is 11. So I have every single side. I have 3 sides, right? And that means for this, okay, let me do it in the next video. Bye for now. Let's stop this one here.